Okay, so this is a problem from section 2.1. You have given a graph, and based on this graph, you need to find out average velocity and instantaneous velocity. So this particular problem gives you clear idea how to, what's the difference between them or how you can find them using the graph. So there are three parts, part A through C, and in each part there are different subparts. So I'm going to click completed work just to show you how many different questions you will be able to see. So as you can see that part A has one, two, three different situation, but by using the same idea you can solve all three of them. Part B, again, one, two, three, but you just need to use the same idea. And for finally, part C, um, so just one part. So if I just unclick this, so completed work, then it's going to give me another new problem. Okay, let's answer this question. First question is, which of the following is the bicyclist average speed? So as you can see that this graph represents the graph between time and distance. As time passes, the bicyclist, you know, um, this is the distance covered by the bicyclist. For example, after 1 hour, bicyclist would travel, at 15, um, miles. Okay. So at 2 hours, bicycle would be still at 16 miles, at 3 hours, and then keep going. That's the distance traveled by bicyclist as time passes. So first question, which of the following is bicyclist average speed? So to find out the average speed or average of any function, you need to know this formula, average of a function f of x. For example, your function is f of x. In this case, it's a distant function, but for any function, if you would like to find the average of that function on the interval a to b, so this is the value of the function on y-axis, and this is the value of the x variable from point A to point B. So for example, let's say this is the function f of x, and then you want to find out the average value of this function from A to B. So how do you do that? The average value can be found by using this formula, f of b minus f of a over b minus a. So find the difference between the value of the function at b minus the value of the function at a over the difference between these 2 points. So this is the formula we're going to use to solve this problem. We would like to find out the average speed. So speed is actually distance over time. So the distance at 1 minus distance at 0 divide by the difference between these 2 points. Okay, that's how we find. Okay, so in this problem, part A here, the average speed is distance at 1, which is, if you look at the graph, distance at 1 when time is 1 is 15. Is that 15? No, it's a 14. Let me zoom in. At 1 the distance is 14, at 0 the distance is 0. Okay, so at 1 the distance is 14, at 0 the distance is 0. So f of b minus f of a over b minus a. B is 1, a is 0, so it's a 14 over 1, so it's a 14 miles per hour. So that's a speed. Since the graph is going up, that's why, and then using this formula, as you can see that it's a 14, so the answer for this is 14 miles per hour. Okay, excellent. And now you can do the same thing for this one. Find the value of the distance at 2.5 minus the value of the distance at 1. So look at the graph here. When the time is 2.5, the distance is 16. When time is 1, the distance is 14. So 16 minus 14 is 2 over the difference between 2.5 and 1 is 1.5. So 2 over 1.5 is what is that? Um, 2 over more time distance, the difference between the distance when time is 2.5, which is 16, and time is 1 is 14. So 16 minus 14 is 2 over 2.5 minus 1 is 1.5, which is 3 over 2. So that means that would be 4 over 3, which is approximately 1.3. By using the same idea, whatever we did here, we can use exactly the same idea and we can find the answer. I'm going to use the same trick for the next, the difference between the distance at 3.5 minus the distance at 2.5. So look at the graph and you see the distance at 3.5 is, look at the graph here, it's 26 minus 2.5 is 16. So 26 minus 16 is 10. Divide by the difference between these two numbers, which is 1. So that is basically 10 miles per hour. Okay, so that's average speed. And now it's time to find out the instantaneous speed at a fixed point, at a fixed time. So at half hour, when time is half hour, what is the speed of this bicyclist? At half, we know the bicyclist is traveling, the distance traveled by the bicyclist is, it's in between 8 and 10, which is I think it's a 9. I would say it's a 9. The distance is 9. That is the distance traveled by a bicyclist when time is half hour. But we would like to find out exactly what is the instantaneous speed, what is the speed at that point. And for that, we need to find out the slope of the tangent line. If we draw a tangent line through this point, we need to find out the slope of that tangent line. Okay, so if you just draw a line through this point, tangent line, as you can see that if it goes from here to here, I cannot show you drawing on this particular graph here, but if you just draw here, then it will be you will be able to find out the slope of that line by using the rise over run, so in this particular graph, this is part B. In this particular graph, as you can see that so let's say this is the point where you want to find out the slope of the tangent line, then just draw a line through this, and then now the slope of this tangent line at this point is actually rise over run. So that means you need to find out the difference between the y coordinate over the difference between the x coordinate. Okay, so slope can be found by finding rise over run. So in this particular case, we would like to find out slope at half. So here, if you zoom in and then try to draw a line from here. You see that rise over run. So you can see that the rise would be 1. It would be 2. That's the difference between these two lines, which is 8 and this is 10. So it's a 2. Rise is 2. And what is the run? Run is the point here, which is I would say it's a 0.5. So it would be 0.7. No, it's a 0.5. So let's say from here to here. So I would say it's a, if you divide this these lines here, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So it would be approximately 0.6 minus 0.4. So 0.6 minus 0.4 is 0.2. So the average, if I just copy that thing here, then here is the lines. This is 8 and this is 10. This is 10. Okay, and this is now there is a graph at half. This is t equal half. At half there is a graph, and if I draw tangent line at that graph, I would be able to see something like this, which is at this point you can see that the value of the distance is 10. So rise over run means this rise, which is 10 minus 8, which is 2. Run is, I think it's because t is half, which is zero point 0.5. So this is approximately zero point 0.6 and this is approximately zero point 0.4. So the run would be zero point 0.6 minus zero point 0.4, which is zero point 0.2. So rise over run is 2 over zero point 0.2, which is what is that? Rise over run, which is 2 over zero point 0.2, which is 2 over 2 over, if you divide 2 by zero point 0.2, it is approximately 10. Okay, so we are trying to find out the answer, which is positive answer, which is approximately equal to 10. So look at the answer given choices here. So as you can see that the choices are two negative values, so we can ignore these two choices, and two positive value, and we need to choose one of the answer which is close to 10, and in this case it's a 14.7. Remember, here I'm just trying to choose trying to find use the approximate values. There is no way I can use exact value, okay, because this my approximation zero point 0.6 and zero point 0.4, it's actually not exactly zero point 0.6, it's maybe point zero point 0.7 minus point 3, something like that. So but it will tell you the approximate value, and then if I check this answer, 100% I will have the right answer, because the choices they give us, one would be close to that approximation and another one would be very far, and two of them would be negative value, which doesn't make sense, because the graph is rising, so its slope would be positive. Okay, let's check one more thing. What is the instantaneous speed at t equal 2? So t equal 2 means, look at the graph. If I just look at the graph here, when t equal 2, if you try to draw the tangent line here, the slope of that tangent line, because it's a horizontal line, it would be 0. So I don't have to do anything. The answer would be it's a 0. There is instantaneous velocity, which is 0. Make sense? Finally, one more example about the instantaneous speed at t equal 3 hours. Remember, one more time, there are four choices. We need to find out the right choice. At t equal 3 hours, if you look at the graph here, when t equal 3, t equal 3 means this is the graph, and try to draw a tangent line here. If I try to draw the tangent line through this point, I will have a point, the line passing through this point, and that line will cross this line somewhere here, this line somewhere here. So that means the rise would be 20 minus 16, which is 4, and the run would be this point to this point, which is, let's say this is 2.25, and this is 3 point what is that, 3.25. So 3.25 minus 2.25 is 1. So 4 over 1 is approximately 4. So that is the answer which is close to 4 is 5 here. Okay, where is that? The answer which is close to 4 is 5 here. So that's the only possible answer, because two of the answer are negative, so they are not right choice, and one is very huge, another one is close to the approximation we got. Though we got 4, but that is the approximation value, that's not exact value, so we need to choose which is close to 4. And that's how you find the instantaneous speed. I hope it helped you, and this video was basically about how to use the graph for finding the instantaneous speed. There is one more question, I'm not going to answer that question. That's